Hello, everybody again. As I said, I work for Ripple as developer advocate, which means that we're in this team trying to help developers to start their journey, understanding what the ledger is, and in general, like to find what are the blockers for those developers to succeed in their path to become successful entrepreneurs using the XRP Ledger. I started my career working in the mobile payment industry before. This is when I was living in Mexico. I'm originally from Mexico. I was trying to help with financial inclusion efforts. So mobile money at the time was like the hot topic. And one of the things that I wanted to work on was honestly doing mobile money international. And to me, that was like the biggest and most compelling challenge at the time. And that's how I ended up like learning about blockchain, because the problem that we had at the time is, okay, there's mobile money emerging in different countries, but how do you make it compatible? So there was like a missing piece, because if you have something like PayPal, at the time PayPal was already working in the US, and we were developing something very similar for different countries in LATAM, but I was like, how can we make these systems compatible? Like, it seems like these companies don't trust each other. So to me, like there was like a missing piece that needed to be there in order for these systems to be able to trust, like almost like a money translator. That's what I was thinking. Whoa, so that piece of software or technology to become like a money translator, that was the thing that I became obsessed about. And in 2012, I started like Googling a ton, and I found Bitcoin, like a trustless, counterparty-less asset that actually you can use as a money translator. And to me, that was the value proposition that I saw. And after that, I became really obsessed. And honestly, that was my journey, finding about XRP Ledger, which in a way, the idea that I'm going to be talking about is not only having that counterparty-less asset that I will explain what it is. It's like basically you don't need to trust. If you have PayPal dollars, so you're trusting PayPal to have money in a bank account. That's the counterparty that in the case of cryptocurrency you don't have. So if you have XRP or if you have like Bitcoin, essentially like there is no one to trust. Right? And to me, that concept is what enables this interaction of companies and people in the internet that don't require to trust each other, and that makes like a different level of integration of money and transfer of value. So that's how I ended up learning about XRPL. At the time, it was an early nascent project. But thinking along like exactly the lines that I was thinking about, I experimented with it, built a solution that moved millions of dollars between US and Mexico. It was early, so early that like the regulatory stage was kind of unfortunate. Some of the partners at the time that we were using obviously stopped operating due to regulatory concerns, and I ended up working in different projects, from parametric insurance using smart contracts on other blockchains, to like the idea of issuing, for example, a Mexican peso and launching that in 2019. And so I've been looking at these solutions from the technology aspect and also like the regulatory. So that's my background, and the idea of today is really to go through these four things. So I'm going to talk about what is the origin of. Sorry, there are many of you here who understand very well blockchain, but I'm going to still walk you through the entire process from the beginning. Just bear with me the idea is for everybody to get a grasp of what we're talking about. Because the whole point of this talk is to give an introduction so that you have a mental model and a map of what you are going to be building, what it's going to be in the back, behind the scenes, so that you feel comfortable about the fundamentals. So I'm going to be talking about that. I'm going to be talking about specific characteristics of XRPL as a blockchain. I'm going to be talking about a use case that it was the one that was initially conceived by the people who built the XRP Ledger, that it's this community credit, that it's possible at the protocol level to build a community credit. I'll talk specifically about that use case and how the same primitives can be used to issue like stablecoin. And I'm going to talk a little bit more about the ability to utilize this technology, basically the same one, to tokenize assets, which is essentially what people are talking about. So I will try to walk you through the entire process so that you go from where we're coming and where we're going. First, blockchain. Why did we need blockchain? I briefly mentioned one thing that was not possible before blockchain, but to be a little bit more precise, the problem that blockchain solves is double spending. It's as simple as that. Like people think that, oh, cryptography, and it's easy to think that maybe if you, people will talk about keys a lot, and maybe people may think that the innovation is about like public key cryptography, which is like this technology that allows you to sign digitally messages. And I just want to be clear that that technology exists since the 80s, and that's not what blockchain is about. That is a piece of what a blockchain is. It's needed, but essentially what a blockchain solves is this problem of ordering transactions, which transaction comes first, and that is what allows you to don't have a double spend problem. The double spend problem is as simple as that. Think digitally, you can use like cryptography to create a digital message that says, I'm gonna send money from Marco account to Thibaut's account, and I'm gonna like use public key cryptography to sign the message. And what that means, and that thing was possible in the 80s, is that someone can actually verify the integrity, that actually it's for the amount and the accounts that are part of this transaction. Someone can verify the integrity of the message, and someone can verify with that digital signature like the source of the message, that I am actually the one creating the. So that kind of like seems enough, right, to create digital money. The problem that we have, and this is just to separate like these two concepts of blockchain and digital signatures, the problem is that you end up with a digital check, but you still don't know which check comes first, right? I can write a check to Thibaut, and I can afterwards write the same check to Florent. And the problem with that is that I can double spend money, right? So it's like in a community, this technology was not enough to create digital cash precisely because you don't know which transaction comes first. So what is the solution besides like creating like this digital signature? Well, you need a system to basically understand what's the order of these transactions, to set everyone, to put everyone on the same page. And that is essentially what the Bitcoin paper is about. How to order transactions in a way that no one is in control of, and that people can understand who owns what, right? And how does it work in Bitcoin is like all of these messages saying, sending money from A to B. You create a list of transactions in what it's called a block, which is essentially a list of transactions. And then you create a fingerprint, a digital fingerprint or a hash that represents uniquely that block of transactions. That fingerprint, it's also included in the next block. And so you create like a chain of trust. So someone can verify without the need of anyone else that there's a valid chain of transactions from the very beginning. So if I go and get like the XRPL like core node system or a Bitcoin node, what I'm going to be doing is checking from the very beginning these fingerprints and how it relates to the other one to the very beginning. So I have all the information without anyone else to make sure that the transactions up to today they are valid. So you can think this as a timeline of transactions. That's what it is. And the other thing, it's not only that data structure, it's also that no one, not a single entity will be in control of that data structure. So you will distribute it in a peer-to-peer network. So a peer-to-peer network is formed by these computers or nodes, and they become the entry point, and everyone will have a copy of that. So that combination of creating that data structure over a peer-to-peer network, that's what makes a blockchain. So the only thing that I didn't talk about was kind of like the way that to create new blocks or new transactions, but there are multiple ways to do it. Like for example, proof of work, proof of stake, proof of authority. But at the end of the day, they will end up all in peer-to-peer networks, and they will have a similar structure. If you have questions, let me know and feel free to interrupt. So if Bitcoin solved the problem, why do we need more blockchains? Well, the problem with Bitcoin specifically and the way it works with something called reorganization. So Bitcoin essentially is this list of transactions that I mentioned that are produced by design every 10 minutes. So by a system called proof of work. So proof of work, to way simply about it, it's like a lottery system where someone will be winning this lottery every 10 minutes, and they will get rewarded for that, for the creation of a new block. And then a little bit of newly created Bitcoin will go to that person. It's incentivized. And then anyone looking at this network will look at which one is the longest chain, and that will become like the source of truth. So if you want to see like who owns what, you will like get this software, you will get the history of transactions, and you will also look at what is like the chain that is the longest, and I will trust that because that's the one that has more amount of work created over, so it's harder to replicate. And so that's as simple as that is the system of Bitcoin. The problem is that sometimes what it seems the longest chain is it will not end up being like the longest chain. So I don't know if you've used a Bitcoin exchange, for example, like there's a number of confirmations. So what that means is that maybe another part of the system, like someone may be creating like blocks and eventually become a longer chain. And so there's a reorganization. It's actually not an attack or anything like that. This happens often. And the problem with this is that you cannot fully trust a transaction even if it's like included in a block. And that's why like some exchanges will wait 3 confirmations for the chain in order for them to credit you the money, right? So I'll send a Bitcoin transaction and the exchange will say, well, I will wait for confirmations from different nodes, and until that moment, I will credit your Bitcoin to your account.
I can just ask a
Yeah,
question?
Please.
You mean that it's like the time to be sure that the transaction isn't in an orphan block, something?
Orphan? Well, in Bitcoin, there are no orphan blocks. So orphan blocks is a concept that was introduced on Ethereum, like to basically, essentially, it's exactly creating a block in parallel, but also like incentivizing that, because here the problem is that only the one creating like a block, it will get like the reward, right? So in a way, like you have in parallel people working on the same. It's a very redundant system. So you can create incentives in multiple ways, in which like you can either pay or not people that have like those new newly created blocks. But the point is that it's a very competitive system, that in parallel people are trying to build like a longest chain, and sometimes there are reorganizations. So you don't, what you do is basically wait a little bit and see, okay, this block has a lot of confirmation from the network, so it's really not feasible that it will be replaced, so people trust it. But what this creates exactly, it's probabilistic finality in Bitcoin. So you don't have what it's called deterministic finality, which essentially it's like what you have in a bank. Like in a bank is the transaction, it's atomic, either happened or did not happen. That's how we think about money. In Bitcoin, you don't have that concept. It's always probabilistic. Like nothing except like probability guarantees you that the transaction happened, right? And that is very weird for banks. As I said, like the way to mitigate it is just to wait for confirmations. But at the end of the day, it's not impossible. It's maybe minuscule, the possibility of someone coming up with another chain, but there are like even papers about this, right? So for example, there's something called selfish mining, like someone creating blocks with a lot of hashing power, and then they will come to the network and they will basically publish that network that you selfishly, because you independently created more blocks with a lot of computing power, and then that creates a reorganization, and that is basically what a potential attack of the network is. Obviously, you need a lot of money to do it on the Bitcoin. That's why like it's kind of like something to understand. But you see the concept that the finality. If you're trying to buy a coffee, right? Because a lot of people put that example. Like this system seems like not very adequate. So the point of XRPL started as thinking, okay, Bitcoin solved the problem. Let's not try to create a better Bitcoin. So this is maybe some people may say that, but the reality is more, how can we create a system that uses some of the innovation that Bitcoin came up with, but for all of those use cases where Bitcoin is not shining? That's kind of like a better way to look at it. Because if you start thinking of blockchains as everyone being a competitor to each other, then you're missing the point. The point, I think the visionary thing about XRPL is like realizing that it's a world with multiple chains, right? I don't think the existence of XRP makes Bitcoin obsolete. It's like almost the opposite. It's Bitcoin has been winning in one use case and makes like this harder money in a digital way, but with a lot of flaws for some use cases. And the realization that this is a great trust model for digital money, but that it's going to be not applicable in multiple situations that have to do a lot with payments. That's exactly what the innovation is about. It's about thinking what are like the other areas that Bitcoin will not cover never by design. And I'm mentioning Bitcoin a lot because that's what existed at the time. So we're talking about 2012. So maybe Ethereum didn't happen until 2015, which was I think when the ICO happened. So this is going back to those days. No one had created a different chain. Everything was a fork of Bitcoin. Litecoin existed already, and a few others that were trying to replicate and do a little bit of something different. But in reality, the XRPL was the only one rethinking the whole thing, like thinking from first principles. What is really Bitcoin? What is it solving? And how can we create a system that is complementary for this future where multiple blockchains will exist? So how does XRPL compares? Well, it has a similar chain of trust. Instead of blocks, people in the ecosystem call them ledgers, but essentially it's a list of accounts with all of the attributes that account has. So it's a different, let's say the data structure is different. So Bitcoin for you may know, but it uses a very simple method of accounting, which is called unspent transactions, unspent transaction outputs, but that essentially like abstracts away. So it's basically just every transaction generates like new unspent outputs, and that's how you track all of the money, but you don't have the concept of an account and an attribute that can be like the balance of the account or the balance in a different currency of the same account. That model, which is the one that Ethereum has, like it's the same in XRPL. Like that's the account model. So we have this account, and those accounts can have changes, plus or minus, like tokens or XRP, and every 3 seconds, there's a process in which all of the different nodes of the network come to consensus, like realizing what are the proposed changes by any participants, and if they comply with all of the rules, they are accepted, and they become part of like the next ledger or version of the ledger that happens every 3 to 5 seconds when the ledger closes. So I'm starting to use vocabulary that you will find in the documentation, but initially some people may call them blocks, but if you find like something like a ledger version, it refers to the same thing. So it is a blockchain in the sense that it creates a chain of trust that also creates fingerprints, that is included as a header, as a part of like the digital object to the next block, and it creates this canonical source of truth. And that's what makes it part of like the same family of protocols as Bitcoin, and it's why it's known as a blockchain. And in the same way that Bitcoin, that data structure is replicated in a peer-to-peer network, so no one is in full control of it, so you don't have to trust an entity to have like that structure of data, that chain. So you can actually essentially, the same way that Bitcoin does, you can have your node and you can verify by yourself. Maybe you cannot create new blocks, but you can verify from the very beginning, this complete sequence of hashes that are linked to each other. So a way to conceptualize what XRPL is. So all of this history to create an abstraction and a mental model of blockchain is basically something similar to Bitcoin. It's essentially a network that allows you to add from any of the entry points in a peer-to-peer network transactions that are not only limited to the transfer of the native token, which is what Bitcoin allows you to do, but also expanding the number of functions that the network offers to any participant. So think of functions that are offered to anyone using the system. It can be a payment, which is like a transfer of XRP, but it can also be a transfer of a token that you can create. And it can also be an offer to exchange one type of token for another. And eventually those functions can be expanded and new functionalities can be added to the ledger to the system in a way that I will talk more about. But those are all available to anyone using the network. Is there a question so far? Okay, so that's just to give you a little bit of a model. So how does these rules evolve over time? If I said like in the very beginning, so NFTs was not a concept in 2012. So NFTs, it's a functionality, including like the ability to trade your NFT. It's a function that was added later in the future. So the whole point of this is that the participants of the network will have the ability to agree not only on the new versions of the ledger, they will also agree on what are the functions, right? Because those are part of the rules. Kind of like what a blockchain does is like a redundant computation of the same thing. So like the Bitcoin network, they all process transactions. They will verify that it's valid, that someone had funds in order to transfer those funds. And in the same way, XRPL does the same thing, checking that you had enough balance in order to send that balance to another account, so they can be easily verified. And the same way, if you want to create something like a transaction that it's more like an offer in a decentralized exchange, that it's part of the set of functions of the ledger, and the same thing to mint an NFT and create a ledger object, and maybe offer that NFT in exchange for that. So the whole point, think of these as ossified smart contract functions, but instead of creating these, like the ability of new programs and then embedding those new programs as a smart contract, which is kind of like the mental model of someone building on Ethereum. So this is like the idea, and a whole concept is that it's a system that it's less programmable by design, so that it's ossified in a way that it allows more security and more reliability to the operation of the ledger. How does the chain then evolve over time in terms of what it allows, what rules are potentially possible in the system? Well, that was another visionary thing about XRPL. It's how to manage the evolution of the ledger, right? And some people call this governance, because every ledger, the issue is that these are systems that they're created to last hundreds of years, right? Because if you have money and we want to compete with gold, basically you need to build systems that are hard enough to resist like the pass of time. And that is really hard. And that is like one of the reasons why we want to have less programmable. Less programmability means more security, means like less computation for the nodes. So that means that less beefy machines are needed. And being lean when you are in a journey to a couple hundred years, like it's important. So we need to save energy because it's a marathon. So in order for this technology to evolve, unfortunately, not everything is code, right? This is hard. This is a hard truth for Bitcoiners. But like, not only code is needed. There is something around the code that actually needs to exist in order for these systems to evolve over time. Why? Because you need to make changes to the code. And the second thing is because you need to allocate resources. Like you need to, at the end of the day, developers need to eat. Why? I need to eat. So even paying that development it's a real problem. So you can think of Bitcoin the way it works, and this is just to demonstrate that there's some organizational structure needed for the evolution of a system, even like Bitcoin, that it's lean. Like Bitcoin, you can think of this as code, right? That if you go to Bitcoin D, you will see code. And that's the code that the nodes in the network will run in order for the system to operate. But what happens? Who proposes changes to that code? Well, today, developers that work for companies, right? Blockstream like employs people who are core developers in Bitcoin, but also independent developers who have been from the very beginning. But these have different ideologies. So the different ideologies make that this is an adversarial task. Someone wants the protocol to do one thing that is different from the vision that other company may have. So you always have different visions of what the blockchain is, trying to propose changes to the code so that the protocol is optimized for their purposes. And that is why some governance is needed, right? So there's a book about what Bitcoin experienced a few years ago, which is the block wars, which is essentially this. It's like people trying to propose changes so that you have a larger block and you can include more transactions. And then that obviously makes all the fee structure different, so transactions can cost more or less. And so, but the problem is that you need computers then to have more power, so it becomes a more centralized network. So like you have that problem of two different visions of what the ledger is, and you need governance, right? So it's that's a demonstration that even like a system like Bitcoin needs governance. So how does XRPL innovates in that? And this is also one of the reasons why I think XRPL was visionary, was let's embed in the code the ability for the nodes that are operating the system to signal what version of the code they're running. So it allows the nodes to coordinate on the different versions of the code so that they can, I will not say vote for new changes, but to signal to the other peers what is the code that they want to build. So even like if there's a fork, at least you have the ability to signal and communicate at the protocol level. And this is like this system that it's known as amendments, which is just the ability to introduce new changes to the ledger, like the ability to mint NFTs and trade those NFTs. But you have the possibility of the existing nodes to signal the approval of this new code. Because at the end of the day, in XRPL, these nodes are not incentivized to produce new blocks the same way as in Bitcoin. It works with the idea of let's create this network of trust between these peers, and because you have a voice in the evolution of the ledger, you're incentivized to run a node, right? Not because you're getting paid every new block. You're incentivized to run a node because you want to have a voice on a ledger that you're using for your business and your economic own purposes. And today that's so as an example of that, if you are building let's say an NFT marketplace on XRP Ledger, at some point you will feel that all of your business depends on the evolution and the future of the network. So you're incentivized to run an infrastructure because what you want is to have a vote, right? So it allows you to participate. So it's to incentivize people in a different way, that it's not paying money like to miners, that they will immediately, dump the reward that the network is giving to them. But this is like a more abstract way to incentivize the people to participate.
I have a question.
Yeah.
Are all votes equal?
Well, yes, but not like, let's say, I will talk like this basically will address your question. Essentially, there are like several classes of nodes, as in Bitcoin, right? So Bitcoin started with the idea that all nodes were equal, but at some point, like the code diverted, and so miners started to be different from full nodes. I'll explain more in the next slide what this represents. But in the case of XRPL, you can think of this as two classes of nodes. One is the ones that participate in consensus, that are in charge of producing new ledgers, new blocks, and the ones that are just users, right? So the users, the same way as in Bitcoin, the non-mining blocks, they don't have that voice power. Why? Because the whole point here is to have a subset of the nodes signaling just trust among each other by creating like this mesh of trust, which is the way that it's formed. It's basically, today it works very off-chain. So basically this is technology and this is not technology. So today there are entities that they check the track record of nodes, and essentially they just propose and create lists of, this is a recommendation of the nodes that have a good track record of being available, and essentially every node will create their own list of who are the peers that seem to be like legit and trustworthy. And basically each of the nodes will put that list in their code that they run, and that creates a mesh between a subset of the nodes that essentially Ripple also publishes a unique node list. And in principle, the nodes are free to put whatever list they want. And in the future, maybe someone like Commons can also publish like a list of unique nodes that they think they're trustworthy. And that creates this mesh of trust. And the consensus and the amendment process works in a way that you only need 80% of that subset of nodes. So you can think of, these are the ones that show a track record, the people agree that they are going to be available and they're trustworthy to not cheat. And essentially, they are the ones who have the governance power. And you only need 80% for changes or for blocks, and that's what makes it fault tolerant. So you can have some nodes that maybe they're not malicious, but they're not available. And you also can see the network evolve over time, creating new blocks, just with 80% plus. So essentially, some concept that it may not be easy to grasp is that you have two classes of citizens, like in Bitcoin. You have the subset of, let's say, consensus nodes, and you have user nodes. And people easily can say, okay, well, only the nodes who participate in consensus matter. And the reality is that actually history has proven that to be not the case. So for example, at the end of the day, these nodes are validating transactions from the very beginning. So they have power. So it's not that someone can just alter the code, because that will be verified also by a user node. So in Bitcoin, again, this happened in the block wars. And essentially, one proposal was, okay, let's not, us that we don't participate in consensus, let's not pay attention to the blocks that have the rules that we don't agree with. And so that creates the possibility for those non-mining nodes to organize themselves, right? And there's nothing preventing them from forming like a new mesh of trust, which essentially will be a fork with the new rules. So what I'm saying is that you have power even if you don't participate just by participating in the network. So this is well documented in what happened with these block wars, because essentially Bitcoiners said, okay, let's create something called user-activated soft fork, which essentially means a number of nodes that don't agree with certain rules that they don't consider should be part of the protocol. So what you will have at the end of the day is that you will have a subset of maybe, like let's say these validators who actually have a voice in the governance, maybe adopting new rules, but the rest of the network cannot. Then at the end of the day, you will have a fork. And then you will have then the ability for them to say, okay, the community did not want what we thought it was like the proper set of rules, and we're going to go back to this other newly created fork. So essentially, you have tools to coordinate towards what the users really want. So the whole conclusion here, to be very simple and plain simple, is every node matters, because you're verifying transactions. You're using your computer to verify like this chain of trust since the very beginning. So also, obviously, there are different roles. Like some of them will keep the data of the transaction. Some of them will just keep like headers, as I said, like to create to save some space. So you have like full history nodes, and you have some nodes that only keep history. Like there are certain configurations, but they all are running the same code base, which is Ripple D. So just to start talking about what today and tomorrow is going to be about, what I've been talking about is this network that is formed by these peers that are running the code that I described, what it's used for, that it's written in C++, and that is abstracted away. And the idea is for everyone to participate in the network and to build apps that can include transactions and get value from this network, but to don't have to get involved in all the things discussed. That's what makes it difficult in other blockchains. So the point is that you can see that as a black box. Each of the nodes of the network, it's a black box, and it has the ability to talk to the real world, that it's the Web 2, the web world, using HTTP protocols, right? So you can you can talk to that weird network that I talk, how it evolves and how it was created and what it solves, in a way that you don't have to interact with those components, right? How? Through HTTP, obviously. You can either use WebSockets that opens by directional communication channels, or you can use JSON RPC. And obviously, we have libraries. Ripple is one contributor that has created libraries so that any developer with JavaScript or with Python can just abstract away some of these things that are needed. I will walk you through the most important ones, but the idea is that you don't have to learn a new programming language. You don't have to go and maybe try to alter the code in C++ at the core level. You just have to see what are the functions that are available today, what are the ones that I need, and you can interact with them very easily by communicating through HTTP, by creating like objects and transaction intents that you will be sending to the network, and in order for the network to discuss among the peers and approve or reject the transaction. Okay, so I have 5 minutes, and I'll start describing the use cases that the network launched with. One that the reason why I found XRPL really interesting, it's because, and this may be very surprising for people, because people think XRPL, it's kind of like related to Ripple, and Ripple is about banks, so it's like the blockchain for banks, right? And I'm here to kind of like be on the other side and saying like, well, actually, it was the opposite for me why I came to the ecosystem. And this is why I want to put this as an example, because this is what actually one of the reasons why I thought, okay, this kind of like is challenging the existing power structures, and I found it compelling. So one of the projects that preceded like the blockchain, it was called Ripple, essentially was trying to create software for this use case. So think of a community where there's a winemaker, and the winemaker obviously like gets some money every year, like, and because they have some liquidity constraints, they need to wait until the grapes are ready and all of that, you know that well. So they will not have money until a certain time of the year. So they need to eat, but like the developers. So they have next to them like a cheese producer and also like the butcher. And maybe they trust the winemaker. So essentially, what they would do, and you can do today, it's to signal the trust in the blockchain. There's a ledger object called trust line, where basically it's a unidirectional signal system where you can trust, for example, an entity, and what that allows is for that trusted party to be able to make you payments. But in that trust line that has a currency, for example, you can say dollars, and an amount. I trust the winemaker up to $1,000 because I know he's gonna get paid eventually by the people buying the wine, and he will be able to pay me back. So what I produce, I'll give it to him. And by creating this trust line, you're signaling at the protocol level that he has the permission to make a payment of that currency to you, and basically creating money out of thin air, backed only by the trust that you signal through the protocol. So these lines, like the green one and the purple one, are showing the things that happen at the protocol level. These things happen in the real world. So the real value is the meat, is the cheese, but you are using a protocol to coordinate like how that real value in the world is transferring to each other. And then that's kind of like simple, but then think about it. You're creating money out of trust, and then you have the ability with these units of account, the ability to make payments directly from that party because of that trust exists. So you create a network of trust, and you create the ability to make a payment from the cheesemaker to the butcher. So I think at the end of the day, you can create a currency out of trust in a community base, and this honestly challenges like the power structures like at the extreme, right? Obviously, you can see why this hasn't been fully adopted. There's like a counterparty risk. So what if this guy goes away, everybody's using credits, and there will be no money. So in an ideal way, this guy will get paid and will replace those credits. Okay, he becomes a bank, and then he will exchange those credits. Once he got paid, he sold already the wine, and he will exchange those credits for real gold, for example. So that is cool, but also think the same primitives can actually work for that case that I just talked about. So think of a bank replacing the winemaker and essentially using like the same primitives. Now you signal the trust. The banks, they're not great people, so basically they will not take your meat or your cheese, but once you sell it to others, you will get gold from those others, and you will be able to deposit those gold coins, and the bank will issue a credit, and this is a more sustainable and scalable system, and this is how a stablecoin works. You put money in an entity that is regulated and that is authorized to perform this activity. You will signal the trust. Once you deposit money, they will create those units, and you will be able the same way to use those unit of accounts to create money. And this is essentially what, using the same protocol, you're able to operate a stablecoin. But it depends really on the people, how do you use the protocol? So the protocol is not opinionated. So what I'm trying to demonstrate here is that you can use the same tools to serve a bank, or you can use the same tools to serve a winemaker. And it's really on the developer to decide which use case dominates. And to me, that's really powerful. And just in 3 minutes to be less abstract and kind of like how this looks in code, kind of like to show you if a developer in Python wants to implement this trust line and then the payment that comes with the trust line. So essentially, you have all of these classes and models in Python that they will abstract away all of the complex communication, because probably you have experience with blockchains. Normally, you need to send all of the information in hexadecimal. Sometimes, like you need to serialize things. So all of that is abstracted away in these libraries. So to show you how simple it is, you essentially will have these functions that will help you instantiate the objects that in the format that the network is able to read and digest. For example, in this case, as I said, the trust line will include a currency, will include the issuer who you're trusting, and the amount. And then you will use this class, like issued currency amount. It's available. I imported here these from that module, and essentially it will allow me to basically have a limit amount and an account. That those are like the two parameters that I can pass to the trust set function that I also imported, and that's going to be able to create the object that you need to send to the blockchain for it to validate it. And then there, as I said, like there are different ways to talk to the ledger. One is like opening WebSockets, sending an object, and getting a response in the same channel. Or also one is to use like JSON RPC. So this one uses JSON RPC. So essentially you create a client by saying, okay, this is like the network, this is a test net. I'm gonna create an object that it's the client that I will need to use to submit a transaction. And essentially you will have the ability to, in one single step, to do the digital signature, and also to fill the gaps, because the transaction object needs some things that probably you would not need in the very beginning, like for example an expiration date that it's measured in the number of the block or sequence. So all of that you don't need, they become optional parameters, so you will get less errors, and you will be able to safe sign a transaction, autofilling like those missing parts, and essentially once that you create like the transaction object, you will be able to send it and submit it to to the ledger, you passing also like the client object that I talked about briefly, and essentially that will be enough to send a transaction. And then if you want to check what happened, you will also have like one model that it's about requests. So some of the models are about sending transactions, and some of them are about requesting information. So this one is to request information, and you will just pass, for example, the hash, that it's just the digital fingerprint of the transaction that you just sent, and you will be able to check if the transaction was validated by the network. So at the end of the day, all of the validation and all the complex things becomes like a true or false flag that you will be able to track if you know the hash. So you will ask to the ledger, what happened with this hash that corresponds to this transaction where I tried to create trust, and then the network will basically respond with true or false if it was validated or not, and this one just prints it. So this is all I had. I tried to go from like the big picture to the very pragmatic way. The whole point of today is to essentially, maybe not in Python, in JavaScript, like to go deep into what does it mean to build an application, but the whole point is for you to understand what happens and what's behind and who controls the network and why does it exist, and I hope you found some value. So much.